Welcome to the section on problems for the rectangular coordinate system. You will not see any trigonometry in here, but this is preparation for graphing so that we can graph trigonometric functions starting in the next section. Again, I like to refer to the problems as A, B, C, D, E, and F, and if we're still using the 5th edition from McKeek's Trigonometry, then the page numbers would be the same, and the problem numbers would be the same, and the chapter numbers would be the same. Otherwise, I would have to change that, and that's if we don't use that book anymore in the future after 2007. I don't know, maybe we'll use it forever. That's why, but anyway, that's why I refer to A, B, C, D, E, and F. So let's get started. It says, graph each ordered pair on a rectangular coordinate system. So the points 2, 4, 2, negative 4, 2, negative 2, 4, and so on. So I'm going to do all these points, and I'm going to go to Paint to do that. Let's see. So it says to graph the point 2, 4. Well, there it is. Maybe make it bigger, I guess. There we go, 2, 4. So graph the point 2, negative 4. So there it is. To graph the point negative 2 and 4. So let's use a different color here. Negative 2 and 4. To graph the point negative 2 and negative 4. There it is. And it's obvious you know that from previous classes that the first number refers to the x-axis and the second number refers to the y-axis, and of course quadrant 1, quadrant 2, quadrant 3, quadrant 4, and here you have positive x and y, and here you have negative x and positive y, and so on. And of course that's what I base it on. Okay, let's do a few more. Next point is negative 3 and negative 4, so that will end up right here. Whoops, nope. I counted the boxes wrong. Negative 3 and negative 4. Negative 4 and negative 2. So that will be here. 5 and 0. Let's see. 5 and 0, which will be here. Negative 3 and 0. There it is. 0 and negative 3. I'm going to change colors. 0 and negative 3. And 0 and 2. So there they are. I'm going to save this one here, because I like to use it later on and paste it into our Word document. Let's go back to Word, and let's see what the next problem says. Okay, in fact I'm going to do the next 2 problems. Okay, it says, graph the parabola y equals x plus 2 squared plus 4, and then graph the parabolas y equals x minus h squared for h equals negative 3, for h equals negative 3, h equals 0, and h equals plus 3. For a regular parabola, the way it looks is that we would have square root of, I'm sorry, not square root, parentheses x minus h squared plus k, and what the k means is it's the vertical, well, going vertically up or down, and the h means going horizontally left or right. Notice that there's a minus in between, which means a positive h means we go to the right, which and negative h, which then makes the whole thing positive, means we're going to the left. So in this one here, that's what we're going to start out with. You would actually have to imagine there's a minus -2. That means we're going 2 to the left. And here we're going 4 up. On the next example, it would mean minus -3, so we're going 3 to the left. And then it says 0, so we actually stay at the origin. And then it says minus +3, so we're going 3 to the right. And here the vertical shift, that was our shift, vertical shift is 0, so we stay on the x-axis. Let's go over to Paint and graph these parabolas. And then after that, we're going to go to the graphing calculator and graph them. And I'm not the best in graphing, especially with a mouse. So the first one says that we have to go 4 up, and then we have to go 2 to the left. Remember that +2 actually means minus -2. So our vertex will come out here. And we have a parabola that opens up, so it's going to look something like this here. Wow. Pretty bad, huh? Let me see if I can do this any better. Probably not. Piecewise. Yeah, piecewise works a little bit better. There we go. And then the next example, what it means is we start out with x minus -3. So we have a vertex here. And then again, we have a parabola that opens up. As I said, the vertical shift here on this one was 0. Then we have x minus 0 squared, and let me use a different color for this one. So green right here, and then it's set here to draw them all in the same coordinate system. And it says 8x minus +3 squared. So here we have, so there's a certain overlap here. I don't know exactly where that is, but ooh, that was interesting. How did that happen? Whoops. Alright, there. It's alright. Let's go to the graphing calculator. Alright, so y equals. And the first example said, open the parentheses. I hope it's going to do this and not freeze up on me. This is interesting. I might have to do that in the next session, because right now it seems like the graphing calculator is frozen up on me. I can do certain things, but I can't do everything. You know what? I'm going to close this down here, and I'm going to try to pause. I'm going to pause and see you in a little. So I'm back, and I hope our graphing calculator will work this time. It's very encouraging. This happens the very first time around. Okay, parentheses x minus 2 squared. Oops, that was actually a +4, and that was actually a plus right there. So there we go. And then we graph. And there it is. There's the parabola, and that's what I showed in Paint, that it shifted 4 up and 2 to the left. Okay, the other 3 So that would be x minus negative 3 squared and x minus 0 squared and x minus positive 3 squared. And I'm going to turn the first one off. There we go. And hit the graph button. And let's see, it seems like I'm using, there we go, there's the first parabola, and there's the second parabola, and there's the third parabola. Seems like my computer is using a lot of memory here, so it's getting a little tough for the computer. As I said, I will take these here later and paste them into the Word document that we have. In fact, I'm going to take a snapshot of this right now. Yeah, there we go. Okay, let's go back to Word and see what other exercises we have left. Okay, I'm going to scroll down. I said this will be a little bit more busy later on as I graph all these, or as I insert all these graphs here. Okay, here it says, find the intersection of the circle x squared plus y squared equals 25, and the straight line x plus y equals 5. And then I think I'll do the other two here later. Find the distance between the points. Yeah, I'll come back to it. Let's go over to Paint. And let's move over here. So these are your graphs on the right-hand side. I'm going to take a circle here and graph this one. And it says x squared plus 5 plus y squared equals 25. So that would be a circle with, okay, maybe not here. Let me start over again. Of a radius of 5. And so maybe I should start here. Whoa, that's a big circle. A radius of 5 and the center at the origin. And then it says x plus y equals 5, and which is a straight line. And the easiest way to graph that actually would be to find where the x-intercept is, and the x-intercept is where y equals 0, and so x would have to be 5, and where the y-intercept is, and at the y-intercept x equals 0, and therefore y equals 5. So there we go. And here's the straight line through these 2 points. There we go. And I guess I can. There we go. And of course, where they intersect is, let me see if I can make this a thicker line. I hope actually you see the circle. So there's the thick straight line. Let me make the circle thick as well. Well, actually, I don't know if it allows me to do that. I don't see that function here in Word. I'm sorry, in Paint. Anyway, the intersections are at x equals 5 and y equals 5. Okay, now let's go back to Word and let's see the last 2 exercises, which says find the distance between the points 4, 7 and 8, 1. I will go to Paint in just a moment, but pretty much what we know in order to find the distance is that we make a Pythagorean triangle out of it, and what we'll figure is that, let me shift this a little bit down here because I need the square root sign, is that the distance comes out to the square root of, I'll call this here little d, of the difference of the x value. So 8 minus 4, so 4 squared, plus the difference of the y value, so 7 minus 1 squared, and then of course take the square root of that. And I will graph this in just a moment when I go back to Paint. So this one here is 8 minus 4 squared, and then it's 7 minus 1 squared. I didn't feel like writing this down here as 7 minus 1 squared. So we have 36 plus 16, and take the square root of the resulting 52. And of course I do this on the side. I don't need to show you that. A little over 7, right? 7.2. And I might as well do this one here, because it's the same kind. By the way, there's no additional problem here. And what we have here is negative 10 minus negative 1. So that comes out to a negative 9. And I may want to put that maybe 9 in parentheses here. And then we have 5 minus negative 2. So we have a positive 7 that's being squared. And so we're going to have 81. Notice, of course, negative squared is positive. 81 plus 49. So we take the square root of 130. So we're going to have 11.4 as the answer as I do this here on the side. Let's see what we come up with in Paint. I'm just going to do this in Paint. I'm going to save this here. I'm trying to open, yep, here we go, a new one and graph these points here. So I'm going to have 4 and 7. Let's see, I'm going to use the lower one here, 4 and 7. So this is actually the lower graph here. Let's see, 4 and 7, 8 and 1. Whoa. 8 and 1. So actually notice that I'm a little bit off the graph here. Actually, let me see if I can take part of this away. Yeah, there we go. Let's just get rid of the next graph here. There we go. And let's get rid of part of this graph here as well, so I can actually do something there. So I'm in this graph here, and then I put a straight line through the points. Let's see how good I can hit this. That's not too bad. Actually, I was just supposed to do the exact distance between those 2 points. There we go. And I guess we have here, we have the 4, and then here we have the 6, and then again it's 6 squared plus 4 squared, which is 52. Take the square root of 52, and that came out to the, what was that, 7.2, I guess? Yep, 7.2. Okay, and the other exercise was -1, -2 was the point. So there it is. Or there it is. Let's use a different color. There we go. And the other point is -10 and 5. Oh yeah, okay. Oh, bummer, bummer, bummer. I'm off the paper. Let's see, maybe I can fix that while I'm in session here. Let's see if I put this over here. There we go. Okay, that's not too bad. Okay, I want to say -10 and 5. So we have -5 here, and -9, -10, and 5. So I would be over here. There we go. put a straight line in between those two. So there it is. And then when I count these out here, I have 9 on the horizontal, and I have 2, 7 on the vertical, and it's going to be 81 plus 49, which is 130. Take the square root, which comes out apparently to 11.4. And with that one, I'm finishing this session. And as I said, I will be inserting all these graphs that I just did, that I just made.